There is a piece of wood in a museum in Turin that has been sitting in a glass case for over a century, and most people walk past it without stopping. It fits in one hand, roughly half a meter long, painted in faded colors, marked with careful lines, dividing it into sections and subsections with a precision that was not achieved carelessly. The edges are worn, not from age alone, though it is very old, from use, from being picked up and set down and picked up again, thousands of times, by hands that are long gone. That rod is approximately 3,000 years old, and the length of it, the precise distance from one end to the other, is a number that some researchers believe may be mathematically related to measurements proposed at Stonehenge, and to proportions suggested in monuments built in Peru by people who, as far as the historical record shows, never knew Egypt existed. Whether that is true is a question that serious researchers have been arguing about for more than 50 years. The argument has produced careful fieldwork, rigorous statistics, genuine discoveries, and genuine disagreements. It has not produced a conclusion that everyone accepts. Tonight we are going to follow that argument where it leads, not to a verdict, to a place where the question becomes clear enough to hold in your mind, and honest enough to be worth holding through the dark. Someone made that rod to a specific length on purpose. We are going to spend tonight trying to understand why. Find a comfortable position. Let your breathing slow. You do not need to follow every detail. If you drift somewhere in the middle of all this, that is exactly as it should be. The question will still be here when you come back. It has been waiting for thousands of years already. It can wait a little longer for you. Chapter 1. The Problem with the Numbers. On a summer morning in 1954, a man named Alexander Thom parked his car on a narrow road on the Isle of Lewis, off the northwestern coast of Scotland, and walked across a field toward a group of standing stones that had been there since before writing existed. He had a notebook. He had surveying instruments calibrated for precision. He had been doing this, driving to stone circles and megalithic alignments across the British Isles and measuring them with the care his engineering background demanded. Since the 1930s, this was not a dramatic morning. It was another morning in a decades-long project that most of his academic colleagues regarded as an eccentric hobby pursued by an otherwise serious Oxford professor. The site he was visiting is called Callanish. It is one of the most striking megalithic complexes in the British Isles. A central circle of 13 tall stones surrounds a single monolith nearly 5 meters high, with 4 rows of stones extending outward in the approximate directions of the compass points. The whole complex covers an area roughly the size of a city block. It was built approximately 4,500 years ago, and nobody alive has ever known with certainty why. Thom measured it. He measured the distances between stones, the diameter of the circle, the spacing of the rows. He wrote the numbers down. He moved on to the next site, and when he came home and laid his data out and began looking for patterns, he found something he could not explain away. The measurements from Callanish, like the measurements from dozens of other sites he had visited, did not produce clean numbers when expressed in meters or feet. The distances came out irregular, fractional, apparently random. But when Thom began experimenting with a different unit, a unit of approximately 0.83 meters, the numbers began to change. Diameters that were irregular in any modern unit came out to whole numbers of this new unit. Spacings that had seemed arbitrary became clean multiples. Not always, not perfectly, but with a consistency that was enough to make Thom take the possibility seriously. By the time he published his findings in a book called Megalithic Sites in Britain in 1967, he had measured more than 300 sites across England, Scotland, Wales, and Brittany in northwestern France. The data filled hundreds of pages of careful tables. He called the unit the megalithic yard, Its proposed value was 0.8297 meters. Now, before we go any further, the most important thing to understand about Alexander Thom is who he was and who he was not. He was not a writer of popular books about ancient mysteries. He was not a fringe theorist working outside the academic mainstream. He was a professor of engineering science at Oxford University, trained in the precise measurement of physical systems, and his work was published by Oxford University Press. It was taken seriously enough to be engaged with, debated, and in some cases directly challenged by professional archaeologists and astronomers for decades after his death. That engagement is where the story gets genuinely interesting. In 1999, a professor of archaeoastronomy at the University of Leicester named Clive Ruggles published a thorough reassessment of Thom's hypothesis. Ruggles had spent years working with the same kinds of sites, and he brought to the question a level of statistical sophistication that had advanced considerably since Thom's original work in the 1960s. His conclusion was careful but pointed. He acknowledged that Thom's fieldwork was careful and his data largely reliable. The measurements themselves were not the problem. The problem was the interpretation. When Ruggles applied rigorous statistical analysis to the question of whether the spacing of stones across multiple sites reflected a single underlying unit, he found that the evidence was considerably less compelling than Thom had presented it. The range of variation in the measurements was large enough that the apparent unit could, he argued, be an artifact of the analysis rather than a reflection of something the builders had actually used. In statistics, this is sometimes called a phantom unit. If you take a large enough dataset of measurements and search hard enough for a repeating pattern, you will almost always find one. The question is whether the pattern was put there by the people who built the things being measured, or whether it appears because the human mind is extraordinarily good at finding patterns even where none exist. Ruggles was not saying that Thom had been dishonest. He was saying that the methodology carried an inherent risk of producing a false positive, and that the evidence for the megalithic yard had not yet cleared the bar above that risk. Thom's defenders responded. The debate continued. Neither side has produced a knockdown argument. Neither side has walked away. And that persistence, the fact that serious researchers on both sides continue to find the question worth arguing about, tells you something important about what kind of question this actually is. It is not a question with an easy answer. It is not a question that the evidence has settled. It is a question that an Oxford engineer with a transit level and 3 decades of fieldwork put into the world, and that the world has not yet finished answering. The megalithic yard may be real. It may be a statistical artifact. The tools we currently have for deciding between those two possibilities have not produced a verdict. But here is the detail that makes this more than a local debate about prehistoric Britain. The proposed value of the megalithic yard, 0.8297 meters, is within the margin of variation in the evidence, approximately 1.5 times the value of an ancient Egyptian unit called the royal cubit. 1.5. Not 2. Not 3. Not some complicated fraction. 1.5. That relationship, if it is real and not a coincidence produced by searching through enough combinations to find one that fits, is the kind of thing that keeps researchers awake. Because if a unit proposed for stone monuments in Scotland has a clean numerical relationship to a unit used in the construction of monuments in Egypt, then either the two units share a common source, or some form of connection existed between those cultures, or the relationship is a coincidence that looks far more meaningful than it is. All 3 possibilities are uncomfortable in different ways. We are going to follow each of them. Into Egypt first, where the evidence is the strongest, where the measuring rods still exist, where a man named Flinders Petrie spent 2 winters in the 1880s measuring a pyramid and produced numbers that people have been arguing about ever since. But before we go there, we need to understand something about where all measurement begins. not in palaces, not in temples, in the body, in the distance, from an elbow to a fingertip. That is where we go next. Chapter 2. The Body as the First Ruler. Before there were kings who decreed the length of a cubit, before there were committees of scientists who defined the meter by reference to the circumference of the earth, before there was any institution at all with the authority to say this length and not some other length is what we will call 1 unit, there was a person standing in front of a problem. The problem was simple. Something needed to be built. It needed to be a certain size, and the person building it needed a way to communicate that size to the other people helping. Today and tomorrow, and in the seasons that followed, the solution was already attached to their body. This is not a poetic observation. It is a documented historical fact that appears across virtually every culture that has left any record of its measurement practices. The earliest units of length that archaeologists and historians have been able to identify are almost universally derived from parts of the human form. The cubit is the distance from the elbow to the tip of the middle finger. The foot is roughly the length of an adult human foot. The span is the distance across an open hand from thumb tip to little fingertip. The digit is the width of a finger. The fathom, still used in nautical measurement today, is the distance between the fingertips of both arms stretched wide. These units did not require anyone to invent them. They required only that someone notice them. A person building a wall does not need a ruler if they can say, "Place this stone 3 forearms from the corner." A weaver measuring cloth does not need a tape if she can say, "This length is 4 spans." The body was the original portable measurement device. Always available, always approximately consistent, always understandable to anyone else who also had a body. The word cubit itself comes from the Latin cubitus, meaning elbow. It is one of the oldest measurement words in any language, and its root tells you everything about where it came from. Not from a decree, not from an astronomical calculation, from a person bending their arm and noticing the distance between the joint and the fingertip. Now, here is where this becomes directly relevant to the question we are building toward. The fact that ancient units derived from the human body is, on the surface, a perfectly reasonable explanation for why similar units appear in different cultures. If the cubit is approximately the length of a forearm, and human forearms across different populations vary within a range of perhaps 15 to 20% around a mean, then you would expect cubit-based measurements in Egypt and Mesopotamia and the Indus Valley to fall within a fairly similar range. Not identical, not precisely the same, but in the same general neighborhood. And that is largely what we find. The Mesopotamian cubit varied across different periods and regions, but generally fell between about 45 and 56 centimeters. The Egyptian royal cubit, in its most carefully documented form, sat at approximately 52.3 to 52.4 centimeters. The Hebrew cubit referenced in biblical texts was approximately 44 to 48 centimeters. None of this is mysterious. It requires only that human beings in different places noticed the same convenient feature of their own anatomy and used it as a baseline. So far, the body-based explanation is doing its job comfortably. But here is where it begins to strain. The body-based explanation works well for explaining why similar units exist across different cultures. It works considerably less well for explaining why specific units appear to repeat with a precision far greater than the natural variation in human body proportions would predict. The difference between a cubit of 45 centimeters and a cubit of 56 centimeters is significant. A building designed around one and a building designed around the other will be measurably different in its proportions. When researchers look at the most carefully preserved ancient structures and attempt to reconstruct the units actually used in their construction, they sometimes find units that repeat not just approximately, but with a consistency that is difficult to explain purely by reference to anatomy. And here is where the most important physical evidence enters the story. Not the buildings. The buildings require interpretation, measurement, and statistical analysis that can be contested. The most important physical evidence is the measuring rods themselves. They still exist. Several examples of ancient Egyptian measuring rods, including examples of the royal cubit, have survived and are held in museum collections around the world. The Egyptian Museum in Cairo holds examples. The Museo Egizio in Turin holds one of the most complete and well-preserved examples known. These are physical objects, typically made from wood or stone, divided into subunits by careful markings, and preserved well enough that their total lengths can be measured with modern instruments to a high degree of precision. When you measure them, something quietly remarkable happens. The surviving royal cubit rods are not all identical. They vary slightly from one another, as any collection of handmade objects will, but they cluster around a value of approximately 52.3 to 52.4 centimeters, with a consistency that goes well beyond what you would expect from rulers derived purely from whoever's arm happened to be convenient at the time of manufacture. These rods were calibrated against something. There was a mechanism for maintaining their consistency across time and across the different workshops and construction sites where they were used. Someone was keeping the standard. What that mechanism was, precisely, is not entirely clear from the surviving record. And that uncertainty is honest and important. We do not have a complete account of how the Egyptians maintained the precision of their royal cubit across centuries of use. We have the rods, and we have the buildings, and we have the mathematical texts that show the Egyptians using the cubit in calculations. We do not have the equivalent of a metrology laboratory with records of every calibration. This gap is where the debate begins to open. Because once you acknowledge that ancient measurement standards required some mechanism for maintenance beyond simply measuring someone's forearm, you are already in territory where the body-based explanation alone is no longer sufficient. You are in territory where questions about institutional knowledge, the transmission of technical standards across generations and across geography, and the relationship between measurement and the larger systems of social organization become unavoidable. And those questions, it turns out, are the same questions that become urgent when you start comparing the royal cubit to the megalithic yard, and both of them to units proposed by researchers working on ancient Andean architecture, and all three of them to the size of the planet they were all built on. We are not there yet. For now, let the image of those cubit rods settle in your mind. Pieces of wood and stone, some of them more than 3,000 years old, sitting in museum cases in Cairo and Turin, divided into subunits by lines drawn by hands that have been dust for millennia. Still measurable, still precise enough that a researcher with a modern caliper can read the value they were made to express. The body built them. The institution preserved them. And somewhere in the space between those two facts, the question this story is really asking begins to take its shape. What was being preserved? Exactly. And how far did the preservation reach? Chapter 3. Stonehenge and the Megalithic Yard. There is a place in the hills above the Great Glen, about 40 kilometers southwest of Inverness, where a field of standing stones has been drawing people to it for 4,000 years. The site is called the Clava Cairns, 3 large circular burial mounds, each surrounded by a ring of standing stones, arranged so that the light of the midwinter sunset falls through the entrance passages in a way that researchers now believe was deliberate. The builders oriented their monuments to a specific moment in the year, a moment that had meaning enough to organize months of collective labor around capturing it in stone. Alexander Thom measured sites like this one dozens of times across 3 decades. He was not looking for mystical alignments. He was looking for units, for the number that, when you expressed the distances between stones in it, produced whole numbers instead of fractions. For the module that the builders had been working from, whatever it was and wherever it had come from, what he proposed, after measuring more than 300 sites across the British Isles and into Brittany, was a unit of approximately 0.8297 meters. He called it the megalithic yard, and he published the hypothesis in 1967 in a book issued by Oxford University Press, which is not the publisher of last resort for ideas the academic mainstream has already dismissed. The reception was mixed but engaged. Here was an Oxford professor with decades of careful fieldwork and a large data set of measurements spread across a significant geographical range. The quality of the data was not seriously disputed. What was disputed, vigorously, was what the data meant. The central claim was specific enough to test. Tom proposed that the megalithic yard had been used in the design of megalithic monuments across a geographical range of roughly 1,000 kilometers over a period extending from approximately 3000 BCE to around 1500 BC. That is a span of 1500 years. For that claim to be true, the people building these monuments would have needed some mechanism for maintaining the unit with enough consistency to show up in Tom's measurements as a single unit rather than as a range of similar but distinct values. That mechanism is the hardest part of the hypothesis. The period Tom was looking at spans from the late Neolithic into the early Bronze Age, a time of no unified political authority across the British Isles, no central institution that could mandate a standard, no roads, no writing, and significant practical challenges of travel across a landscape of forests and rivers and sea crossings. How does a unit of measurement maintain itself across that kind of fragmentation for 1500 years? One answer that has been proposed does not require institutional transmission at all. It requires a pendulum. A pendulum of a specific length completes one full swing in a specific amount of time. The relationship between pendulum length and swing period is determined by the force of gravity, which is effectively constant at the surface of the Earth. This means that if you want a pendulum that completes exactly 2 swings per second, you need a pendulum of a very specific length. That length, at the latitudes where most megalithic monuments are concentrated, works out to approximately 0.824 meters. That is close to Tom's proposed megalithic yard of 0.8297 meters. Not identical, but within the range of variation that the evidence supports. The pendulum hypothesis is interesting precisely because it does not require any contact between communities. Any group of people who wanted a consistent unit of length and who knew how to use a weighted string as a timekeeping device could independently arrive at a value close to the megalithic yard. The constancy of gravity would do the work of maintaining the standard without any institution, any document, any physical rod passed from builder to builder across generations. But the pendulum hypothesis has a problem. We have no direct archaeological evidence that the megalithic builders used pendulums as part of their measurement practice. The hypothesis is plausible. It is consistent with the evidence. It is not proven by the evidence. And this brings us back to Clive Ruggles and the statistical challenge that has been hanging over the megalithic yard hypothesis since the 1980s. Ruggles's argument was methodological rather than empirical. He was not disputing the quality of Tom's measurements. He was challenging the interpretation of those measurements. The problem he identified is sometimes called the unit fitting problem, and it is subtle enough to deserve careful attention. If you take a large data set of measurements and search for a unit that makes a high proportion of those measurements come out to whole numbers or simple fractions, you will always find one. The mathematics are unavoidable. Given enough measurements, a sufficiently flexible definition of what counts as a match, and a sufficiently wide search across possible unit lengths, you can find a phantom unit in almost any large data set. The question is whether Tom's megalithic yard is above that phantom unit threshold or below it. Ruggles argued, after careful analysis, that the evidence was less compelling than Tom had presented. The distribution of measurements that Tom had analyzed could, in Ruggles's assessment, be explained without recourse to a single shared unit. The apparent consistency might be a product of the analysis method rather than a reflection of actual ancient practice. Tom's defenders responded. The debate continued into the 21st century. Neither side has produced a result that silenced the other. Where does that leave us? It leaves us with a hypothesis proposed by a careful and credentialed researcher, challenged by an equally careful and credentialed researcher, defended by further researchers, and still unresolved after more than 50 years of analysis. What is not in dispute is this. Alexander Thom measured hundreds of ancient monuments and found a pattern in his data that he believed reflected a shared unit of construction. That pattern has been seriously engaged with by professional researchers for more than half a century. The engagement has not destroyed the hypothesis. It has also not confirmed it beyond reasonable doubt. Now, stand for a moment at the edge of what Stonehenge itself shows. Separate from the broader megalithic yard debate, the largest sarsen uprights weigh between 25 and 30 tons. The lintels that connect them weigh approximately 10 tons each. They were moved from a quarry at Marlborough Downs, approximately 25 kilometers to the north. They are connected to the uprights by mortise and tenon joints carved into the stone with a precision that a craftsman working in wood would recognize immediately, and that has held for 4,000 years without any binding material. Someone measured carefully to make that possible. Someone, in the years around 2500 BCE, determined how far apart the uprights needed to be, how high the lintels needed to sit, how deeply the mortises needed to go into the stone, and how tall the tenons needed to rise to meet them. Whether that someone was working in Tom's megalithic yard or in some other unit is a question the stones have not yet answered. But that someone was measuring carefully, and somewhere in the numbers they left behind, the answer may still be waiting. Chapter 4. The Royal Cubit and the Great Pyramid. In the winter of 1880, a young Englishman of 26 years arrived in Egypt with a set of measuring instruments he had largely designed himself and a determination to do something that nobody had done with sufficient care before. His name was William Matthew Flinders Petrie, and he had come to measure the Great Pyramid. Not casually, not as a tourist recording impressions, with the precision that the question deserved and had not yet received. He spent 2 winters at Giza, sleeping in a tomb near the pyramid to be close to his work, measuring the structure and its surrounding complex from base to summit with instruments calibrated to a precision remarkable for his era. Petrie was not a romantic. He was not looking for hidden codes or ancient mysteries. He was an empiricist who believed that the best way to understand an ancient structure was to measure it accurately and let the numbers speak for themselves. When the numbers spoke, they said something interesting, expressed in the unit that the people who built the pyramid had actually used: the royal cubit. The base of the Great Pyramid measured approximately 440 royal cubits on each side. The original height, before the loss of the outer casing stones and the apex, was approximately 280 royal cubits. Those two numbers, 440 and 280, have been at the center of an argument that has not stopped since Petrie published them in 1883. Before we get to the argument, we need to establish what the royal cubit actually was, because it is one of the best evidenced units of measurement in the ancient world, and the evidence for it is considerably stronger than the evidence for the megalithic yard. The royal cubit rods survive, not as reconstructions, not as inferences from architectural measurements, as physical objects in museum collections. The Museo Egizio in Turin holds one of the finest examples known. The Egyptian Museum in Cairo holds several. In total, several dozen examples have survived in good enough condition to be measured with modern instruments. When you measure them, They cluster around a value of approximately 52.3 to 52.4 centimeters. The variation between individual examples is small enough to make clear that these were calibrated objects, made to a standard that someone was actively maintaining, not simply personal body measurements taken from whoever happened to be available. The royal cubit was divided into 7 palms, and each palm into 4 digits, giving 28 digits in a full cubit. This subdivision system appears consistently across the surviving rods and across the mathematical and administrative texts that reference the cubit in calculation. It was a formal system, institutionally maintained, used in everything from the assessment of agricultural land for tax purposes to the design of temple complexes whose proportions were understood to have religious significance. This is the solid ground. The royal cubit is not a hypothesis. It is a documented historical fact, supported by physical evidence that can be measured by anyone with the right instruments and the right permission. Now, back to the Great Pyramid and the argument. The ratio of the base perimeter to the height, when you calculate it using Petrie's dimensions of 440 and 280 royal cubits, comes out to approximately 2 times pi. The perimeter of the base is 880 cubits. 880 divided by 280 is approximately 3.1429. Pi is approximately 3.1416. The difference between those two values is very small. The ratio of the slant height of one face to half the base length comes out close to phi. The golden ratio, approximately 1.618. These relationships have been noted, celebrated, dismissed, and argued about for well over a century. The question is whether they are intentional or incidental. The mainstream Egyptological explanation is this. If you design a pyramid using a slope angle close to 52 degrees, which is close to what the Great Pyramid actually has, you will automatically produce a structure whose proportions are close to those involving pi and phi. You do not need to know what pi or phi are as abstract mathematical constants. You just need to decide on a slope that looks right or satisfies some practical criterion. And the numbers follow from that decision without any deliberate encoding. This explanation is taken seriously by mainstream Egyptology. It is consistent with what we know about how Egyptian architects actually calculated proportions, using a tool called the seeked that measured slope as a ratio of horizontal run to vertical rise. An architect choosing a seeked value that produced a pleasing or structurally sound slope would arrive at proportions related to pi and phi without needing to know those constants explicitly. That explanation has genuine force. It also does not settle everything. The Rhind mathematical papyrus, held at the British Museum and dating to approximately 1650 BCE, demonstrates that Egyptian mathematicians had methods for approximating pi that were accurate to within about 1%. The Moscow mathematical papyrus, held at the Pushkin State Museum of Fine Arts in Moscow, demonstrates comparable sophistication. These are real documents with real content. They show that the people building things in ancient Egypt were not mathematical innocents stumbling accidentally into elegant proportions. Whether they chose the proportions of the Great Pyramid because they understood their mathematical significance, or arrived at them through practical methods that happened to embody those values, is a question that the surviving evidence has not resolved and may never fully resolve. What the evidence does support, firmly and without serious dispute, is that the Great Pyramid was designed and built using the royal cubit as its fundamental unit. The dimensions in royal cubits are clean. 440 and 280 are not arbitrary values. They reflect intentional design to specific proportional targets, whatever those targets meant to the people who chose them. Now the connection that brings this back to our broader question. The royal cubit is approximately 52.3 centimeters. Alexander Thom's proposed megalithic yard is approximately 82.97 centimeters. The ratio between those two values is approximately 1.586, within the margin of variation that the evidence on both sides supports, close to 1.5. Whether that relationship is meaningful or coincidental is a question we cannot answer with the evidence currently available. It is precise enough to be interesting. It is not precise enough to be conclusive, and it is the reason the broader question this video is asking does not go away. Petrie's notebook from his winters at Giza is in the archives of the Petrie Museum of Egyptian Archaeology in London. His handwriting is careful and small. His measurements are precise. He did not know what the numbers he was writing down would generate in the century and a half that followed. He just wanted to know how big the pyramid was. The numbers are still being argued about. Now there is a place we need to go. A continent that had no documented contact with Egypt or megalithic Britain during the periods we have been discussing, where stone platforms built at an altitude where the air is thin enough to feel its absence with every step have been generating their own quiet version of this same argument. The desert behind us, the ocean ahead, a mountain range that touches the sky. That is where we go next. Chapter 5. Peru, and the limits of the evidence. There is a site in the Bolivian Andes, on the southern shore of Lake Titicaca, at an altitude of approximately 3,800 meters above sea level, where the air is thin enough that visitors from lower elevations feel it in their lungs with every step they take up the stone stairways. The site is called Tiwanaku. Picture it for a moment. The lake behind you, enormous and cold and blue at this altitude. More blue than any lake at sea level has a right to be. The sky pressing down closer than you are used to. The stones in front of you, fitted together without mortar. Shaped to tolerances that the freeze and thaw cycles of 1,000 Andean winters have not significantly disrupted. Someone built this carefully. At its height, which researchers place somewhere between 500 and 1,000 CE, Tiwanaku was the center of one of the most significant civilizations in pre-Columbian South America. Its influence extended across a vast region of the Andes. Its architectural achievements included stone construction of a precision that continues to generate serious archaeological attention more than 1,000 years after the city was abandoned. The most studied structure at the site is a complex called the Calisasaya, a large rectangular enclosure with walls built from precisely shaped and fitted sandstone and andesite blocks. Some of the largest stones at the site weigh more than 100 tons and were transported from quarries dozens of kilometers away by methods that are still not entirely understood. When researchers have attempted to reconstruct the unit of measurement used in the design of the Calisasaya and other structures at Tiwanaku, they have found evidence of an internally consistent module, a basic unit that appears to have governed the spacing of architectural features across the site. The value proposed for this unit by various researchers falls in a range of approximately 80 to 86 centimeters. That range includes the proposed value of Alexander Thom's megalithic yard. It also includes values close to 1.5 Egyptian royal cubits. Now here is where intellectual honesty requires slowing down completely and being very precise about what the evidence actually supports. The Tiwanaku unit is a reasonable inference from architectural measurements. It is not confirmed by physical measuring rods in any museum collection. It is not corroborated by documentary references in any surviving text from the culture that built these structures. What we have is the architecture itself, and the architecture requires the same kind of inferential analysis that makes the megalithic yard contested. The honest position on the Andean evidence is this: the measurements are real. The proposed unit is a reasonable inference from those measurements. The comparison to Old World units is a question worth asking. The evidence for any connection between Andean measurement units and Old World measurement units, at present, insufficient to support a conclusion in either direction. That is not a satisfying statement. It is an accurate one. Consider what would actually be needed to move this from an interesting observation to a meaningful conclusion. You would need a large, carefully measured dataset of Andean monuments measured with the precision that Petrie brought to Giza and Tom brought to the British megaliths. You would need statistical analysis that could withstand the kind of scrutiny Ruggles applied to Tom's work. You would need to establish the precise value of the proposed Andean unit with enough accuracy to make the comparison to Old World units meaningful. And you would need some plausible mechanism by which either a shared standard or a shared derivation method could account for any similarity you found. None of those four things currently exist in the literature at the quality level required for strong conclusions. There are researchers who believe the connections are real and who have devoted serious work to establishing them. There are mainstream archaeologists who regard the proposed connections as premature. The debate has not produced a resolution. What the Andean civilizations did have, without any question, is a sophisticated relationship with measurement and recording that deserves to be understood on its own terms before it is recruited into arguments about cross-cultural connections. The most remarkable example of this is the quipu. A quipu is a recording device made from knotted strings. The Quechua word means simply knot. Quipus consist of a main cord from which pendant cords hang, and the pendant cords carry information encoded in the type, position, and number of knots tied into them. They were used extensively by the Inca Empire, which rose to dominance in the 14th and 15th centuries CE. And they appear to have been used in some form by earlier Andean cultures as well. Gary Urton, a professor of pre-Columbian studies at Harvard University, has spent decades analyzing quipus and developing a system for classifying the information they contain. His work has established that quipus encoded numerical information using a base 10 positional system, the same logical structure underlying the numerals we use today. Urton has also proposed that quipus may have encoded narrative or administrative information beyond simple numbers, a hypothesis that is more contested but taken seriously enough to have generated ongoing research at multiple institutions. The relevance of this to measurement is direct. A civilization capable of encoding complex information in a systematic and transmissible physical medium is a civilization that has thought carefully about how to preserve and communicate knowledge across time and distance. The Inca Empire governed a territory stretching more than 4,000 kilometers along the Andes without a writing system in the conventional sense, relying on quipus and on the trained specialists who could create and read them. That level of administrative sophistication requires consistent standards. Consistent standards require a mechanism for maintaining them. The question of how Andean civilizations maintained their measurement standards, and what those standards actually were, is a genuine research question that has not been fully answered. It is a different question from whether those standards were related to Old World units. Keeping those two questions separate is important, because conflating them is one of the ways that interesting observations turn into unsupported conclusions. There is one more thing worth being honest about. When researchers or writers notice that a unit proposed for an Andean site falls in a range that overlaps with a unit proposed for a site in Britain or Egypt, there is a temptation to move quickly from that observation to a conclusion about connection or transmission. That move feels logical. It is not. Two units being similar in value does not mean they came from the same source. Two numbers being close does not mean they are related. The history of archaeoastronomy and ancient measurement research contains cases where an apparent numerical coincidence was treated as evidence of something more until closer analysis showed that the units being compared had not been established with enough accuracy to make the comparison meaningful, or that the apparent pattern was a product of searching through enough combinations to find one that seemed to fit. This is the Andean evidence, held at the level of precision that the evidence actually warrants. The stones of Tiwanaku are real, and they are extraordinary. The measurements of those stones are real, and they are suggestive. The proposed connections to Old World units are real observations, and they are not yet sufficient conclusions. The lake is still there. 2 miles above sea level, cold and blue and enormous, holding the light of the high Andean sky in a way that water at lower elevations simply does not. The stones are still fitted together at its edge. Precisely. Without mortar. By people whose names we do not know, and whose measurement unit we have not yet fully recovered. Whatever they were measuring with, they were measuring carefully. The question of what that unit was, and where it came from, and whether it connects to anything in Scotland or in Egypt, is a question that the evidence has not yet answered. That answer may come. It has not come yet, and the honest acknowledgement of that gap is not a failure of the research. It is the research doing what good research does, holding the question open until the evidence is strong enough to close it. Chapter 6. The Earth Itself as the Ruler. Picture two men walking out of Paris in the summer of 1791, carrying surveying instruments and a commission from the Académie des Sciences. The city behind them is in the middle of tearing itself apart. The revolution is 2 years old. The king is still alive, but will not be for much longer. The streets that Jean-Baptiste Delambre and Pierre Méchain are leaving behind have seen things that nobody living through them fully understands yet. But the two surveyors have been given a task that belongs to a different order of things entirely. They are going to measure the Earth. Not all of it. An arc of the meridian passing through Paris. From Dunkirk in the north to Barcelona in the south. A stretch of approximately 10 degrees of latitude, from which the full distance from the North Pole to the equator can be calculated. From that calculation, 1/10,000,000th of the pole to equator distance will be declared the new fundamental unit of length for the French Republic. They are going to call it the meter. The principle behind the decision is the most radical thing about it. The meter will not be based on any king's body. It will not be defined by any physical rod that a government can alter or a war can destroy. It will be grounded in the earth itself, in a feature of the physical world that no human authority can change and no institution can corrupt. Delambre took the northern section of the arc, from Dunkirk to Rodez. Méchain took the southern section, from Rhodes to Barcelona. Together, they would spend 7 years in the field, measuring across a landscape disrupted by revolution and war. Méchain discovered an error in his own measurements partway through the project. An error small enough that most people would have absorbed it quietly into the final calculation. Méchain could not. He spent the rest of his life trying to correct it and conceal it simultaneously. A private torment that his biographer, Ken Alder, documented in detail in a book published in 2002. The error introduced a tiny inaccuracy into the original definition of the meter that was not corrected until new measurements were taken decades later. The meter they produced was not perfectly equal to 1/10,000,000th of the pole to equator distance. But the principle was clear. For what the French scientists believed was the first time in history, a major civilization had deliberately grounded its fundamental unit of length in the size of the planet. Or, so the story is usually told. Because here is where it becomes more complicated. A small number of researchers, working independently across several decades, have proposed that Delambre and Méchain were not doing something genuinely new. They were, these researchers argue, rediscovering a principle that had been applied before. Applied a very long time before, by the same civilizations whose measurement units we have been examining throughout this video. The argument, in its simplest form, goes like this. If ancient civilizations derived their measurement units from the size of the Earth, the apparent similarities between those units across different cultures would not require any contact between those cultures. They would not require the transmission of knowledge across oceans. They would require only that multiple civilizations, independently, discovered a method of grounding their units in the same physical reality that every civilization shares, because they are all living on the same planet. John Neal, a researcher in ancient metrology whose book, all done with mirrors was published in 2000, has argued that the ancient measurement systems of Egypt, Mesopotamia, Greece, and Rome were all consistent with systematic measurement of the Earth's dimensions. His analysis involves not just single unit values but entire families of related values, each calibrated to specific latitudes and specific fractions of the Earth's surface. This argument is not widely accepted in mainstream archaeology or metrology. It has not been presented in a form that meets the evidentiary standards those fields apply to extraordinary claims. But it points toward a mechanism that, if it were ever confirmed, would change the way we understand the relationship between ancient measurement and ancient knowledge of the physical world. Before we can evaluate that mechanism, we need to understand what method ancient peoples might have used to estimate the Earth's dimensions. The most famous documented example of ancient Earth measurement is Eratosthenes of Cyrene, the Greek mathematician and librarian at Alexandria, who calculated the circumference of the Earth in approximately 240 BCE. He did it by measuring the angle of the sun's shadow at two different locations on the same meridian at the same time of year. At Syene in southern Egypt, the sun was directly overhead at the summer solstice and cast no shadow. At Alexandria, further north, it cast a shadow at a measurable angle. From that angle and the distance between the two cities, he calculated the full circumference. His method was elegant. His result was remarkably accurate, falling within a few percent of the actual polar circumference of approximately 40 million meters. But Eratosthenes was working in the 3rd century BCE, more than 2,000 years after the Great Pyramid was built, and more than 1,000 years after the main phase of megalithic construction in Britain. His calculation cannot be the source of any measurement units in those earlier monuments. If ancient measurement units were derived from the size of the Earth, the derivation must have happened earlier and through a different method. Now picture something simpler. A single stone, roughly the size of a fist, hanging from a length of braided fiber over a fire on a winter night, 4,000 years ago, somewhere on the plain that will one day be called Salisbury. Someone is watching it swing. They have noticed, as anyone who watches a pendulum long enough will notice, that the time it takes to complete one full swing depends on the length of the string. A longer string swings more slowly. A shorter string swings faster. And if you want a pendulum that beats a specific rhythm, 2 swings per breath, 2 swings per heartbeat, you need a string of a very specific length. That length, at the latitudes where most megalithic monuments are concentrated, works out to approximately 0.824 meters. A pendulum of that length, swinging freely, will complete almost exactly 2 full swings per second. That is close to Tom's proposed megalithic yard of 0.8297 meters. Within the range of variation that the evidence supports, now here is the deeper implication that the pendulum observation carries. The force of gravity that determines a pendulum's period is not perfectly uniform across the surface of the Earth. It varies slightly with latitude. Because the Earth is slightly flattened at the poles and slightly wider at the equator, this means that a pendulum calibrated to beat a specific rhythm at one latitude will beat at a slightly different rate at a different latitude. The difference is small, but it is measurable, and that difference, across multiple latitudes, encodes information about the shape of the Earth. Any careful observer who compared pendulum lengths across different locations, who asked why the string needed to be slightly longer in one place than another to keep the same rhythm, could in principle work backward toward an understanding of the Earth's curvature. This proposal is speculative. It is not supported by direct documentary evidence from any ancient culture, but it is not impossible. The people who built Stonehenge were tracking the movements of the sun with enough precision to align their monument to the solstice. The people who built the Great Pyramid were working with proportional relationships accurate enough to produce results within fractions of a percent of mathematical constants. These were not peoples who lacked the capacity for systematic observation of the physical world. The question is not whether they were capable of careful measurement. The question is whether the specific measurement we are proposing, the derivation of a unit from the Earth's dimensions, is supported by the evidence they left behind. The honest answer is that some proposed relationships between ancient unit values and the Earth's dimensions are suggestive rather than conclusive. The royal cubit has been proposed to approach certain fractions of the Earth's dimensions at certain latitudes. The proposed megalithic yard sits within a range that has a plausible relationship to pendulum lengths at the latitudes where megalithic monuments are concentrated. Some proposed Andean units fall in ranges that overlap with values that would be produced by similar methods at Andean latitudes. None of these proposed relationships are confirmed. All of them are worth investigating. Consider the moment when Delambre and Maychain came home from their 7 years in the field and handed their measurements to the committee. They believed they were doing something unprecedented. They may have been right. They may also have been rediscovering something that had been lost so long ago that no memory of it survived in any tradition they had access to. A decision made thousands of years earlier, by people whose names the committee did not know and whose methods they had no record of. A decision that the physical world, and not any human authority, should be the foundation of how length is measured. That possibility cannot be confirmed with the evidence currently available. The Earth that Delambre and Maychain were measuring was the same Earth that the builders of Stonehenge and Giza and Tiwanaku were standing on. Whether they were measuring it too is the question that the evidence has not yet closed. Chapter 7. What the mainstream says, and why it matters. There is a building in the town of Sèvres, just outside Paris, where a small platinum iridium cylinder sits inside 3 nested bell jars in a climate-controlled vault. For over a century, from 1889 until 1990, that cylinder was the kilogram. Not a representation of the kilogram, not a close approximation. The kilogram, by international definition. Every scale, in every laboratory, in every country that had agreed to the metric system was calibrated, directly or indirectly, against that cylinder. In 1988, when the cylinder was brought out and weighed against its official copies for the first time in decades, something uncomfortable was discovered. The copies had drifted away from the original by amounts nobody could fully explain. Nobody knew whether the original had gained mass or the copies had lost it. The most carefully maintained physical measurement standard in the world, stored under the most controlled conditions human beings had ever devised for such a purpose, had proven unreliable after a century. The lesson the international scientific community drew from this was clear. Physical standards drift. Everything changes. The only measurement standards that can be trusted indefinitely are those grounded in features of the physical world that do not change, in fundamental constants that the universe maintains without any assistance from human beings. In 2019, the kilogram was redefined in terms of the Planck constant, a number written into the fabric of physics itself. The platinum cylinder is still in its vault in Sèvres. It is now a historical artifact rather than a definition. This is not a digression from our story. It is the heart of it. Because the lesson that the international scientific community learned in the 21st century, that physical standards drift and only constants are reliable, is the same lesson that may lie behind the question of whether ancient builders grounded their units in the earth. And it is the context in which we now turn to what the mainstream of archaeology and metrology actually says about the claims we have been examining tonight. The mainstream position is not a simple dismissal. It is a set of carefully reasoned arguments built on substantial evidence and serious methodology. And they deserve to be engaged with, fully. Start with the most fundamental objection. Measurement units that appear to be related to each other, or to the size of the Earth, or to mathematical constants like pi and phi, are not surprising discoveries. They are expected outcomes of how measurement systems work and how human analysis works. Given enough units, from enough cultures, and enough ways of expressing the Earth's dimensions, you will always find combinations that produce apparently clean ratios. This is the unit fitting problem. Ruggles identified it in his analysis of the megalithic yard. But it applies far more broadly than that single case. Researchers have demonstrated, using randomly generated sets of numbers, that the same methods used to identify ancient measurement units in real archaeological data will also find apparent units in random data. The units found in random data are not real units, but they look statistically similar to the units found in real data by the methods typically used in this field. That demonstration does not prove that the megalithic yard is not real. It demonstrates that the methods used to argue for it are not sufficient by themselves to establish that it is real. For a hypothesis about ancient measurement to be convincing, it needs to clear a bar that this problem sets quite high. The proposed unit needs to appear with a consistency that exceeds what would be expected from random variation. The analysis needs to account for the number of possible unit values that were tested before this one was selected. And the proposed unit needs to be supported by evidence, independent of the architectural measurements themselves. The Egyptian royal cubit clears that bar. Physical rods in museum collections, documentary references in administrative and mathematical texts, architectural measurements consistent with those independently established values, 3 independent lines of evidence pointing to the same value. The megalithic yard does not fully clear that bar. No physical rods, no documentary references, no corroborating evidence independent of the architectural measurements. That distinction is not a judgment about the quality of Tom's work. It is a description of what kind of evidence is sufficient to move a proposed unit from interesting observation to established fact. Now, here is something worth sitting with, because it points to a real tension in how this question is handled. Imagine a room in a university. Late in the afternoon. The light coming in low through the windows. A graduate student has just spread her data across the table. 3 years of fieldwork across sites in Scotland. A dataset larger than Tom's. Analyzed with statistical software that did not exist when Tom was working. Her numbers show that a unit close to the megalithic yard produces a better fit than would be expected from random variation, even after correcting for the number of unit values she tested. The senior archaeologist across the table asks good questions. Does the proposed unit appear in all site types, or only some? Does the consistency hold when you restrict the analysis to the sites with the most reliable measurements? Have you tested the finding on a held-out dataset that was not used in the original analysis? Those are exactly the right questions. They are the questions that distinguish genuine pattern from noise. And they are questions that the megalithic yard hypothesis, in its current form, has not fully answered. This is not the mainstream, protecting itself from inconvenient findings. This is the mainstream doing what it is supposed to do, demanding that extraordinary claims meet extraordinary evidentiary standards before they are accepted into the body of established knowledge. The same standard applies to the Earth-based measurement hypothesis. The claim that ancient civilizations derived their units from the size of the Earth is more extraordinary than the claim that they derived them from their bodies. More extraordinary claims require more evidence. The evidence currently available does not meet that higher standard. There is, however, a response to the mainstream position that is worth taking seriously. The mainstream default assumption is that the simpler explanation is correct until evidence forces a revision. That is a reasonable default, but it is a default that has been wrong before. Consider what the mainstream position on Neanderthal cognition looked like 60 years ago. The evidence for symbolic behavior, jewelry, intentional burial, was dismissed or explained away. The default assumption was that Neanderthals lacked the cognitive capacity for such behaviors. Then the evidence accumulated, carefully and patiently, until the mainstream position revised itself. Revisions happen. They happen slowly and on the basis of evidence, not on the basis of how interesting the proposed revision would be if it were true. What the mainstream says, in its most honest and careful form, is not that the ancient measurement connections are definitely absent. It is that the evidence currently available does not confirm them to the required standard, that the methods used to argue for them are vulnerable to the unit-fitting problem and to confirmation bias, and that the bar for claiming cross-cultural connection or Earth-based derivation is high and has not been cleared. That position is compatible with the connections eventually being confirmed by better evidence and better methods. It requires the people arguing for those connections to do better work, not to stop asking the question. The platinum cylinder is still in its vault in Sèvres, and the lesson it taught, that physical standards drift and only constants endure, is a lesson that the builders of Stonehenge and Giza and Tiwanaku may also have been approaching in their own way, with the tools available to them, in the only direction available to them, towards something in the physical world that does not change. Whether they found it is the question the mainstream is still asking. It is the right question to be asking. Chapter 8. The Craftsmen Who Never Left a Name. On the west bank of the Nile, about 5 kilometers from the Valley of the Kings, there is a place that has been buried under sand and rubble for nearly 3,000 years. Its ancient name was Setmat, the place of truth. Today, it is called Deir el-Medina, and it is not large. The village occupied an area of roughly 130 meters by 50 meters, a narrow enclosed space surrounded by a wall that separated it from the desert on all sides. At its peak, it housed perhaps 60 to 80 families. It has no pyramids, no colossal statues, no temple complex that draws the tour buses. What it has is documents. The inhabitants of Deir el-Medina were the craftsmen, artists, and workers who built and decorated the royal tombs in the Valley of the Kings and the Valley of the Queens across the river. They were skilled professionals, organized into a workforce called the gang, divided into a left side and a right side that worked opposite walls of the tomb passages, supervised by a foreman, administered by a scribe who kept records of their attendance, their rations, their disputes, and their output. Many of them were literate. At a time when literacy was uncommon, they wrote letters, kept journals, recorded dreams, composed love poetry, filed legal complaints against neighbors. When the village was excavated by French archaeologists beginning in the early 20th century, they found thousands of ostraca, fragments of limestone, flake, and pottery shard used as informal writing surfaces, covered in notes, sketches, calculations, and personal records of every kind. And among the objects recovered from the village were cubit rods, not the formal ceremonial rods made from polished wood or stone that you find displayed in the finest museum cases. Working rods, made from whatever material was available, worn at the edges from use, marked with the subdivisions that the daily work required. The cubit rods of people who built things for a living. Those rods tell a quiet story about how measurement actually worked. The standard was not maintained by royal decree alone. It was maintained by craftsmen who learned their trade from other craftsmen, who calibrated their working rods against the rods of their teachers, who passed the standard to their apprentices the way they passed every other skill of the trade, through direct physical demonstration, repeated until the student's hands understood what the master's hands already knew. The foreman, whose name appears most frequently in the administrative records of Deir el-Medina, is a man called Ka. He served as foreman during the reigns of 3 pharaohs in the 14th century BCE. A career of approximately 30 years. His tomb was discovered intact in 1906 by the Italian archaeologist Ernesto Schiaparelli. Inside it, along with furniture, tools, and personal belongings, was a cubit rod that had been Ka's working instrument across those 3 decades of service. Ka's cubit rod is in the Museo Egizio in Turin now, a few cases away from one of the finest ceremonial cubit rods in existence. The difference between those two objects tells you something important. The ceremonial rod is beautiful, polished wood, careful inlays, markings that are precise and regular. It was made to demonstrate the cubit as a formal standard, probably as a votive offering or an administrative reference. Ka's rod is also well made, also precisely marked. But it has been used. It has the quality of an object that has been held many times, set against many surfaces, that has done the work it was made to do across a long career. It still preserves the length it was made to carry. The standard and the practice were not the same object, but they were calibrated to each other. And the calibration was maintained through a chain of transmission that stretched from the workshops where official rods were made, through foremen like Ka who used them as references, through the craftsmen who calibrated their own working rods against the foremen's, down to the apprentices who were learning their first measurements from the person standing beside them. That chain is invisible in the monuments themselves. When you stand in a chamber in the Valley of the Kings and measure the walls and confirm that the proportions express the royal cubit with a precision that seems almost impossible for human hands to have achieved, you are seeing the end product of that chain. You are not seeing the chain. The chain is at Deir el Medina, in the ostraca and the papyri and the worn working rods and the administrative records that show who was absent on which day and why. The chain is visible, and what it shows is that the transmission of measurement standards was not a mystery. It was a professional practice, maintained by skilled craftsmen who understood that the precision of their work depended on the reliability of their units, and who took that responsibility seriously enough to build a documentary culture around it. Now take this one layer further. The chain we can see at Deir el Medina operated within a single professional community in a single location across a few centuries. But the question our video has been building toward is about transmission across much larger scales, across geographic distances of hundreds or thousands of kilometers and chronological distances of centuries or millennia. How does measurement knowledge travel across those larger scales? The answer the archaeological record most clearly supports is trade. The Bronze Age Mediterranean was a deeply interconnected trading network. Ships carrying copper from Cyprus, tin from sources in Anatolia, gold from Egypt and Nubia, amber from the Baltic coast, olive oil and wine from Greece, and finished goods from dozens of different workshops moved across the sea and along river routes in patterns that recent archaeology has documented in remarkable detail. The Uluburun shipwreck, discovered off the southern coast of Turkey in 1982 and excavated over 11 years through more than 22,000 dives, contained cargo from at least 7 distinct cultural regions: copper ingots from Cyprus, tin ingots possibly from Central Asia, gold and silver objects from Egypt, ebony logs from sub-Saharan Africa, glass ingots from the Eastern Mediterranean, Canaanite storage jars, weapons, tools, and personal items from multiple cultural traditions. A single ship, carrying the products of half a dozen civilizations. That ship was not exceptional. It was a node in a network. And networks move not just physical goods, but the knowledge embedded in those goods. Craftsmen who made objects for distant markets had to understand the requirements of those markets. Merchants who carried goods between cultures had to communicate about quantities, dimensions, and values with people who spoke different languages and used different systems. The practical necessity of cross-cultural commerce created pressure toward the kind of measurement compatibility that would allow transactions to proceed without constant confusion. We do not know exactly how the measurement standards of different Bronze Age cultures related to each other in practice. But we know that the people operating within that network were solving practical problems of cross-cultural exchange every day, and that measurement compatibility was a practical necessity rather than an abstract interest. That is a context in which apparent similarities between measurement units from different cultures become less mysterious than they might seem in isolation. Not because the similarities are proven to reflect a shared standard, but because the mechanism by which a shared standard might have developed or been maintained is documented, real, and does not require anything more exotic than the normal operation of ancient commerce. Here is the detail that the monuments themselves cannot tell you. The people who maintained those measurement standards across that network did not leave their names in the stones. The ostraca at Deir el-Medina survived because the village was buried in sand, and the dry climate of the Egyptian desert preserved organic material for 3,000 years. The administrative records of a trading port on the Lebanese coast, or a megalithic construction site in Scotland, survived in much smaller quantities, or not at all. We are working with fragments, but the fragments are enough to show us something about what the complete picture looked like. The craftsmen who carried the measurements were carrying something more than a number. They were carrying a relationship between a human body and a physical world, established through observation and maintained through practice and transmitted through the most human of all mechanisms, one person teaching another, one generation handing something forward to the next. Most of them were not famous. Most of them left no record of their individual lives. Ka is exceptional precisely because his tomb was sealed and preserved by the accident of geography and climate. For every Ka whose name and tools and working life have survived, there are thousands whose contribution to the chain of transmission is visible only in the accuracy of the buildings they helped to build. The buildings are still standing. The craftsmen are not. But the precision they achieved is still readable in the stones. And the stones, in their patience, have preserved something of the care of the people who placed them. Even when the names and the faces and the voices are gone completely. Chapter 9. The Measurement We Almost Lost. In the spring of approximately 1200 BCE, a scribe sat in a room in the palace at Pylos, on the southwestern coast of what is now Greece, and wrote a series of tablets in a script we now call Linear B. He was recording ordinary things: inventories of bronze, lists of rowers assigned to ships, records of land, tenure, and livestock, the administrative accounts of a palace economy doing what palace economies do, tracking resources, managing obligations, keeping the system running. The tablets were wet clay. When he finished writing, they would be set out to dry. When dry, they would join the other tablets in the administrative archive of the palace, available to the officials who needed them. That was the plan. What actually happened was different. Within a generation of that scribe finishing his work, the palace at Pylos was burned. The fire was hot enough and sustained enough that it baked the clay tablets in the archive, hardening them into something that could survive not just the fire, but 3,000 years of burial in the ground. Without the fire, those tablets would have dissolved back into mud. Without that accident, we would know almost nothing about the administrative life of Mycenaean Greece. The scribe who wrote them did not know his work would survive. He did not know his palace was about to burn. He was doing his job, maintaining the records, keeping the system running, the way the craftsmen at Deir el-Medina maintained the Cubit standard across their careers without knowing that their village would be buried in sand and preserved for archaeologists 3,000 years later. Both of them were keeping something alive without knowing how fragile that something was. The Linear B tablets at Pylos show that the Mycenaean world used standardized weights and measures. The tablets reference quantities in units that researchers have been able to partially reconstruct from the context of the transactions they describe. There was a unit for grain, a unit for olive oil, a unit for bronze by weight. These units appear consistently across the different palace archives at Mycenae, Tiryns, and Thebes in Boeotia, suggesting that some level of standardization existed across the Mycenaean world. Those units did not survive the collapse. When Greek civilization re-emerged from the Dark Age that followed, writing again after a gap of roughly 400 years, using a new alphabet borrowed from the Phoenicians, the measurement system it used was different from the Mycenaean system. The new Greek units were not continuations of the Mycenaean standards. They were new constructions, partly derived from the body, partly borrowed from the Near Eastern measurement traditions that had survived the collapse in Egypt and in the successor states of the former Hittite and Levantine worlds. The Mycenaean measurement system did not decline gradually. It stopped. Within the span of a generation or two after the Bronze Age collapse, it was gone. This is the pattern that the history of measurement follows when you look at it honestly across long time scales. Measurement standards are not durable by themselves. They are durable only as long as the institutions that maintain them are durable. The moment those institutions fail, the standards begin to drift. And if the institutions fail catastrophically, the standards can be lost entirely within the span of a generation. The Egyptian royal Cubit survived for roughly 3,000 years because Egypt maintained the institutional structures that preserved it, the scribal schools that trained the craftsmen who used it, the administrative apparatus that required consistent measurement for tax assessment and resource management, the religious traditions that embedded the Cubit in the design of temples and tombs and gave it a significance that went beyond practical utility. When those institutions weakened in the later periods of Egyptian history, the consistency of the Cubit weakened with them. The megalithic yard, if it was real, did not survive. Whatever mechanism had maintained it across the 1,500 years of megalithic construction did not persist into the Bronze Age and beyond. By the time the Romans arrived in Britain and began imposing their own measurement system on the landscape, there was no living tradition that carried the megalithic yard forward. The unit, if it had existed, had been lost so completely that it required a 20th-century Oxford engineer with decades of fieldwork to propose its existence from the evidence buried in the monuments themselves. That is what measurement death by institutional collapse looks like. Not dramatic, not the burning of a library or the deliberate destruction of records. A slow fading, as the people who carried the knowledge died and were not replaced. As the objects that embodied the standard wore out and were not recalibrated. As the social structures that had given the standard its authority dissolved into the broader disorder of a collapsing world. And then there was nothing. Or almost nothing. Imagine standing in a field in Scotland in the 11th century CE, 2,000 years after the last megalithic monument was built. Looking at the standing stones on the hillside. You are a farmer. Your family has farmed this valley for as long as anyone can remember. The stones have been here longer than memory reaches. The stories about why they were put there have changed so many times across so many generations that they bear no relationship to the actual intentions of the builders. You do not know what unit of measurement the builders used. You do not know that a unit was used at all. The stones are just there. The way hills are just there. Old and large, and not requiring explanation because they have always been part of the landscape. 1,000 years after you. An Oxford engineer will come with a transit level and a notebook and spend 30 years measuring them and propose that a unit of 0.8297 meters governs their spacing. And the stones will still not say whether he is right. This is what the loss of measurement knowledge looks like from the outside. After enough time has passed, the practice disappears. The standard disappears. What remains is the product of the practice. The monuments. The buildings. The proportions. Carrying the unit in their dimensions without any of the surrounding context that would allow the unit to be read directly. The recovery of consistent measurement standards in Europe after the fall of the Western Roman Empire was a slow process that stretched across the medieval period and into the early modern era. The medieval world that emerged from the ruins of Roman Europe did not maintain a single consistent standard. It inherited fragments, local traditions, approximations, and adaptations that varied from region to region and century to century in ways that would have been unrecognizable to a Roman engineer of the 2nd century CE. The metric system, when it arrived at the end of the 18th century, was the culmination of that recovery. An attempt to establish a measurement standard so fundamental, so grounded in an unchanging feature of the physical world, that no institutional failure could destroy it as long as the Earth itself remained. Whether anyone before Delambre and Maychain had used the same principle is the question this video has been circling all night. Here is what the pattern of measurement loss and recovery does tell us. Every time a civilization has lost its measurement standards, it has eventually rebuilt them. Not necessarily the same standards, not necessarily through the same methods, but always by returning to some combination of the human body and the physical world as the foundations from which reliable units can be derived. The body is always there. The Earth is always there. A pendulum of a given length swings at the same rate today that it swung 4,000 years ago. These facts do not change when institutions collapse. And that consistency, the consistency of the natural world as a foundation for measurement, may be part of why different civilizations, separated by oceans and centuries, have ended up using units that fall in similar ranges, not necessarily because they were connected, though connection is also possible, but because they were all standing on the same planet, working with bodies of similar sizes, and solving a problem that has never changed. The scribe at Pylos worked through it with wet clay and a stylus in a palace that was already burning toward him without his knowledge. The foreman Ka worked through it with a worn wooden rod and walls that needed to be right, in a valley where his name and his tools and his working life would be sealed in sand and preserved for people he could not imagine. The builders of Stonehenge worked through it with ropes and levers and a sky they were watching more carefully than we can easily reconstruct. The builders of Tiwanaku worked through it at the edge of a lake 2 miles above sea level, in air thin enough to make every breath a small effort. All of them were trying to answer the same question, quietly, with their hands. How do you make something the right size? How do you make sure the person who comes after you can make it the same size again? Chapter 10. What the numbers cannot tell us. There is a question that none of the evidence we have examined tonight can answer. Not the Cubit rods in the museums of Cairo and Turin, not Petrie's measurements of the Great Pyramid recorded with such care in the winters of 1880 and 81. Not the 300 stone circles that Alexander Thom measured across 3 decades of fieldwork. Not the statistical reanalysis that Clive Ruggles applied to Thom's data. Not the kippis, in their museum cases. Still knotted. Still carrying information that most of us cannot read. The question is this: what did it feel like to be the person who first made the measurement? Not the 1,000th person to use a cubit rod in a tradition already centuries old. Not the scribe at Deir el Medina, calibrating his working rod against the foreman's reference rod as a routine act of professional preparation. The first person, the one who stood in front of the problem of how to build something that would be the right size, who looked at their own body and at the world around them, and who made the decision that this length, measured from here to here, would be the unit by which they would proceed. We cannot recover that moment. The evidence does not reach back that far. And even if it did, the inner experience of a person making a foundational decision about how to organize the physical world is not the kind of thing that leaves a trace in the archaeological record. This is the deepest limit of what the numbers can tell us. They can tell us what unit was used. Sometimes, with varying degrees of certainty. The Egyptian royal cubit is confirmed by physical rods and documentary references and architectural measurements that converge on the same value. A fact supported by 3 independent lines of evidence. The megalithic yard is a serious and unresolved proposal, carefully made and carefully challenged, awaiting the kind of corroborating evidence that would move it from hypothesis to established fact. The Andean units are suggested by architectural analysis and not yet confirmed by anything independent of the buildings themselves. The numbers can tell us that a unit was applied consistently enough to produce buildings whose proportions remain measurable and meaningful thousands of years after the builders died. What the numbers cannot tell us is what the builders understood about what they were doing. When the architects of the Great Pyramid chose dimensions of 440 royal cubits for the base and 280 for the height, did they know those dimensions would produce proportional relationships close to pi and phi? Did they choose those numbers because of those relationships? Or did they choose a slope that satisfied some practical criterion and arrive at those proportions without explicit knowledge of the mathematical constants they were expressing? We do not know. We may never know. Both possibilities are consistent with the surviving evidence. Both are taken seriously by credentialed researchers. This uncertainty opens onto something broader. When a craftsman at Deir el-Medina picked up his cubit rod and set it against the wall of a royal tomb, he was not simply performing a technical act. He was participating in something that his culture understood as having significance beyond the technical. The tomb he was building was not just a building. It was an instrument of a cosmological process, a vehicle for the pharaoh's transformation, a point of connection between the world of the living and the world of the dead. The precision of his measurements was not just professional pride. It was, in his culture's understanding, a matter of cosmic importance. We can see the tomb. We can measure it. We can confirm the precision. We cannot fully enter the world of meaning within which that precision was understood to matter. If the royal cubit was derived from the size of the earth, then, using it in the design of a temple or a tomb was not just a practical act, it was an act of embedding a relationship between the human world and the cosmic world into the very fabric of the building. The building would carry that relationship in its proportions, silently, for anyone with the knowledge to read it. That interpretation is possible. It is consistent with what we know about the Egyptian understanding of the relationship between earthly structures and cosmic order. It is not proven, and the honest acknowledgement of that gap between what is possible and what is proven is what separates responsible engagement with this question from the kind of confident assertion that the evidence does not support. What the evidence does tell us, when you hold all of it together, is something quieter and more durable than any single conclusion. It tells us that human beings, separated by oceans and centuries and mountain ranges and every kind of difference that the world produces in people who never meet, they have been returning to the same problem across the entire span of recorded history and well before it. The problem of how to make something the right size and communicate that rightness to someone else. The problem of how to preserve a standard across the gap between one generation and the next. The problem of what to anchor a measurement to when the person who made the first measurement is gone. And it tells us that the answers they found, the body, the pendulum, the earth, the careful chain of one craftsman teaching another, were not random. They were responses to real constraints. The body is the same everywhere. The pendulum follows the same physics everywhere. The earth is the same size everywhere. The ancient measurements are not mysteries waiting to be solved. They are presences waiting to be understood. A mystery implies a hidden answer that the evidence, properly interpreted, will eventually yield. A presence is something more human, more resistant to clean resolution, something you can spend a long time with and understand more fully over time without ever arriving at the moment when there is nothing left to understand. The craftsman at Deir el-Medina did not know that 3,000 years later someone would hold his rod in a museum in Turin and measure it with instruments he could not have imagined. He knew the wall had to be right. He knew the rod had to match the standard. He knew the work mattered. That is enough. That is, in fact, more than enough. It is the thing that the numbers point toward without being able to say directly. Chapter 11. The Stone That Still Stands. Come back to Stonehenge one more time. Not to the theories. Not to the numbers. Not to the debates. It is before dawn on the morning of the summer solstice. The plain is still dark. The air is cool and very still, carrying the smell of the grass that has grown in this valley since before the stones were placed. The darkness is the particular darkness of the hour before first light. When the sky is not quite black anymore but has not yet decided to be blue, the stones are there. They have been there since approximately 2500 BCE. They have stood through 4,500 years of English weather, through the Roman conquest and the Norman conquest and 2 world wars, through every argument anyone has ever had about what they mean and who built them and what unit of measurement governed their spacing. They are still standing. The largest uprights weigh between 25 and 30 tons. The lintels that connect them weigh approximately 10 tons each. They are curved on their inner and outer faces to follow the arc of the circle they are part of. They are connected to the uprights by mortise and tenon joints carved into the stone with a precision that a craftsman working in wood would recognize immediately, and that has held for 4,000 years without any binding material. Someone measured carefully to make that possible. We do not know their name. We do not know their language. We do not know what they believed about the sky, or why the alignment of this monument to the midsummer sunrise was worth organizing years of collective labor to achieve. We do not know whether they were working in Tom's megalithic yard or in some other unit. We know the stones. Now, move south in your mind. The Museo Egizio in Turin. A room that many visitors pass through on their way to the larger and more dramatic objects. A case containing the belongings recovered from the intact tomb of a man named Ka, foreman of the royal tomb builders during the reigns of 3 pharaohs in the 14th century BCE. Among those belongings is a wooden rod, approximately 52.3 centimeters long, marked with careful lines, worn at the edges from use, made to be held in one hand and set against stone and plaster and the surfaces of walls that were meant to last forever. It still preserves the length it was made to carry. 30 years of daily work, 3 pharaohs, walls and tombs sealed and not opened for over 3,000 years. And the rod that governed all of it is in a museum case in Turin. Still measurable, still precise, still carrying the standard that Ka received from the foreman before him and passed to the craftsmen working under him, and that they passed to their apprentices, and that stretched back in an unbroken chain to somewhere we cannot follow it. Move south again. The shore of Lake Titicaca, at 3,800 meters above sea level. The platform stones of Tiwanaku fitted together without mortar, shaped to tolerances that 1,000 years of Andean freeze and thaw have not significantly disrupted. The lake behind them, cold and impossibly blue at that altitude. Someone measured carefully there too. We do not know their name either. 3 sites, 3 sets of careful measurements, 3 groups of people who understood, in whatever terms their cultures gave them for understanding it, that the precision of what they were building mattered, that the unit had to be maintained, that the work had to be right. The question of whether those 3 sets of measurements are related to each other is still open, being worked on somewhere tonight. In a journal article being revised, in a data set being analyzed, in a field, somewhere, where someone is setting instruments against stones that have been standing since before writing existed. That is what it means for a question to be genuinely alive. Not that no one has tried to answer it, but that the people who have tried have found something real enough to keep trying, and insufficient enough to keep the question open. And the next set of instruments and methods and patient researchers is already forming. Let that be what stays with you as sleep comes. Not the theories, not the debates. The image of a stone placed carefully in the dark on a plain in southern England by someone who had a unit, who had a rod, who set it against the ground and the sky and said, "Here, Here is where it goes. Here is what one looks like. The wind is moving across Salisbury Plain tonight. The same wind that has moved across it since before anyone had thought to measure anything at all. The stones do not move. They are exactly where the measurements said they should be. Let your breathing slow now. The question is in the stones. The stones are in the dark. The dark is quiet. And patient. And very old. If this story carried you somewhere tonight, leave a quiet like to help others find their way here. And if one of these places, the plain, the museum case in Turin, the shore of the lake in the Andes, is still with you as you drift, carry it gently into sleep. The past is patient. It has been waiting a very long time already. It will still be there in the morning. Good night.